We are bathed in a dazzlingly bright light when the sun reaches its zenith during midday. The weaker the light conditions become as the hours pass, until night arrives with its pitch-black darkness. But given that the thousands upon thousands of cosmic light sources that adorn the firmament, why does space appear to us as such a blank entity during the night hours? The question of whether the night sky should not be radiantly bright quickly arises. In the video below, you'll learn why the nighttime view of the stars is accompanied by a penetrating darkness, and why the universe appears to us to be dark. Do you want to join us on our quest to unravel the universe's greatest mysteries? Then remember to subscribe to our channel and turn on the notification bell so you never miss another one of our videos. It's common knowledge that it takes our blue home planet 24 hours to rotate once around its axis. Because of this natural feature, the sun appears to move across the sky during the day to us on Earth. We are deprived of our natural source of light once the sun has passed over the horizon. During the night, all we see in the sky is a pitch-black firmament incapable of bathing our planet in bright light, despite its countless sparkling formations. Assume that the universe is infinitely large and that the distribution of stars is uniform. Isn't it true that the night sky would have to shine as brightly as our sun? After all, there are an estimated 400 billion of these brightly shining celestial bodies in our home galaxy, the Milky Way. Johann Kepler, a German astronomer, became suspicious of the subject. Scientists in the early 17th century saw clear evidence that the universe could not be infinite in the nocturnal darkness. The scientific community was supposed to be spellbound by this great cosmic puzzle. Heinrich Wilhelm Olber's contributions to the field concerning this topic became known as the Olber's paradox in the decades that followed. It's a term used to describe world models that adhere to a perfect cosmological principle. Scientific cosmology's fundamental assumptions are based on the fact that the universe is homogeneous and isotropic. In simple terms, this means that regardless of the observer's point of view or direction of observation in the galactic context, the universe appears the same to him. This means that even over vast distances, an infinitely extended universe must have a uniform distribution of stars. Under these astronomical conditions, every star's light, no matter which direction it came from, would have to hit the Earth sooner or later. As a result, the night sky would have to be as bright as a star's surface. However, a nightly view of the firmament demonstrates that this is clearly not the case, which explains why space is dark. Olbers eventually came to the conclusion that the gases between stars absorb the emitted light during his research. The light paradox in space could be resolved in this way, as well as the theory of an infinitely large universe. However, as we now know, the astronomer made a critical error. If the gas was exposed to starlight, it would heat up and eventually begin to shine brightly. In fact, many astronomers in the past were convinced that the Milky Way would be a sort of island universe. There would be nothing but an infinite void outside our galactic home if this were true. It took until the turn of the 20th century for this widely held belief to be disproved. Experts at the time realized that the alleged nebulae, or faintly glowing formations in the firmament, were not gas clouds, but rather distant galaxies that housed billions of stars. Outside of our native bar spiral galaxy, space is far from empty. As a result, there must be an answer to the question of why the universe appears so dark to us during the nocturnal hours, despite the fact that the distribution of stars within space is not uniform, contrary to the original assumption. The gleaming celestial bodies collect in galaxies, which then form large clusters of galaxies spread out over vast distances. When our gaze shifts to the firmament, however, the basic cosmological principle remains. In an infinite cosmos, we are always seeing the surface of some star, but we must keep in mind that the average distance between our blue home planet and the gleaming bright celestial bodies is simply enormous. This galactic average value is measured in tenths of a billionth 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 of a billion. Remember that a light year is the distance that light travels in a vacuum over the course of a year. While light beams can travel 180,000 miles in a single second, they can also travel nearly 6 trillion miles in a year. This leads to the opposite conclusion, that it takes 10 to the 23rd power years for light from an average star to reach our blue home planet. The issue is that the emitted starlight has simply not had enough time to travel such a great distance. Experts now agree that the universe began approximately 13.8 billion years ago. As a result, the area of the universe that we can observe is far too small to produce a radiating bright firmament of invisible light particles. This implies that in the not-too-distant future, terrestrial night will be accompanied by a dazzling brightness. This will not be the case when we arrive at the galactic point in time when we will be able to survey a sufficiently large portion of the cosmos. The stars in the universe, like all the other celestial bodies that grace space, would have gone out a long time ago. Stars are finite entities. In fact, the sparkling object's nuclear reactions last only a fraction of a second. The night sky, strictly speaking, is not as dark as it appears to our earthly eyes, at least not across all spectral ranges. In reality, the Earth is bombarded from all sides by a weak radiation. These rays have a wavelength of about 0.04 of an inch or 1 millimeter, which places them in the microwave range. This background radiation is a relic of the Big Bang, a phenomenon that can be demonstrated today and is relevant to current research. The temperature of the universe dropped to about 5,400 degrees Fahrenheit about 180,000 years after it was created. Electrons and protons were able to form stable hydrogen atoms as a result of this. In other words, at that time, the cosmos became permeable to electromagnetic radiation. As a result of the universe's continuing expansion, those light particles that were released at the time are still visible to us today in the form of cosmic microwave background radiation. However, much of the original power of this primordial radiation was lost. The cosmic background radiation is now only a billionth of what it used to be. The influence of background radiation originally brightly illuminated the universe. However, because the wavelength of this galactic relic has shifted from visible to microwave over millions of years, we can no longer detect the cosmic background radiation with our human eyes today, giving us only a limited view. In fact, we humans can only perceive a small portion of the available light spectrum. The universe would take on a completely different shape if we were able to perceive infrared in the microwave range. Essentially, experts believe that the visible baryonic matter makes up a very small portion of the total matter in the universe. In essence, this percentage is estimated to be only 4.9%. Dark energy and dark matter account for 68.3% of dark energy and 26.8% of dark matter, in the most recent models, despite the fact that the existence of dark energy and dark matter has yet to be proven experimentally. They are certain to play a dominant role in galactic constellations and processes, according to researchers. With the help of dark matter, hypothetical dark energy can explain the universe's unexpectedly accelerated expansion. As a result, the visible matter's movements can be classified. However, the universe's continued rapid expansion not only causes a reduction in the radiance of cosmic background radiation, but it also causes another circumstance that contributes to the fact that the night sky appears deep black to us. As previously stated, the Big Bang occurred approximately 13.8 billion years ago, and matter, space, and time originated from an original singularity. The universe began to expand, and this expansion has continued to this day. In layman's terms, this means that all structures in the universe are moving away from their original location. This also implies that the gaps between individual cosmic structures are constantly widening. This includes the countless stars, because these natural sources of light in the universe move even further away, literally scattering the pitch-black areas that lie between these massive assemblages of celestial bodies. We'd like to hear your thoughts, so please leave your suggestions and feedback in the comments section. Thank you for your interest. Take care, and we'll talk again soon.